Okay, in the last video we talked about rates of change, and I mentioned that one of the calculations that we did was exactly a slope calculation. In this video we're going to focus a lot more on the actual slope calculation. I'll remind you what we did in that last video. What we did is we first found the distance between the 2 points on our line in the y direction, or the change in y as we call it. And in this case, our y value of this point is 3 and the y value of the other point is 1. So to find that distance, we just take 3 minus 1. And we call this the change in y. And we can also call this the rise. Then what we did is we found the distance between the 2 points in the x direction. So in this case, our first x value is 5 and our second x value is 2. So to find that distance, we took 5 minus 2. Now we call that the change in x, and we can also call it the run. We define the slope as the change in y divided by the change in x. Using our other definitions, we could call that the rise over the run. And given our numbers in this example, the rise is 3 minus 1, and the run is 5 minus 2. Then finding the slope of this line is just a matter of doing the simple calculation. That's 2 over 3, or 2/3. So the slope of our line in this example is 2/3. And just another piece of notation, we often refer to the slope as m. All slope calculations pretty much go exactly like this, with a few minor complications that we'll talk about in this video. But what I want to do is I want to take a closer look at the calculation that we just did. In this example, we were given 2 points. I'm going to call 2,1.1 and I'm going to call 5,3.2. Within point 1 and point 2, I'm going to label the x and y values. So I'm going to call the number 2 x1. It's the x value from point 1. I'm going to call 1 y1. It's the y value from point 1. With 5,3, I'm going to do the same thing. I'm going to call this x2, and I'm going to call that y2. Now what I want to do is come up with the general formula that we can use to calculate any slope given 2 points. So if we look at our calculation from our first example, we ended up getting that our slope was 3 minus 1 divided by 5 minus 2. Well, if we compare those numbers to what I just labeled over here, what we really have is y2 minus y1 divided by x2 minus x1. And that is going to be our general formula for our slope. I'll write it down. There's our equation. Anytime we want to calculate the slope of a line and we're given 2 points on the line, we can use this formula right here. All you have to do is label one of the points point 1 and one of the points point 2. That allows you to label x1 y1 and x2 y2. All you have to do is plug them into this formula and that'll give you your slope. Now you might be asking, what if we labeled this point 2 and what if we labeled this point 1? It actually doesn't matter, and you should check it, verify to make sure that that's the case. No matter which point you choose as point 1 and which point you choose as point 2, as long as they're both on the line, doesn't matter what order you do it in, your slope calculation should come out the same. Let's look at another example. Let's find the slope of the line between the points 2, -6 and 1, 3. Now you'll notice a couple things are different here. First, we have a negative number, and it's not something to worry about as long as we know how to deal with negative numbers. The other thing that's different about this example is we're not given a graph, and we don't need a graph to find the slope between 2 points. All we need is this equation right here. So what we want to do first is label x1, y1, x2, and y2. So I'm going to choose that this point here is point 1. So that makes that x1 and y1. And this point here is going to be x2 and y2. Now you could reverse 0.1 and 0.2, and your numbers should come out in the end the same as mine. Let's plug all of those numbers into our slope formula. We have m equals y2 minus y1 over x2 minus x1. Now let's plug all of our numbers in. 3 minus negative 6 over 1 minus 2. Do the fairly simple calculation. 3 minus a negative 6 is a positive 9, and 1 minus 2 is a negative 1. So what is 9 divided by negative 1? Well, 9 divided by 1 is just 9, and the fact that there's one negative either in the numerator or the denominator means you can just call that a negative 9, and that's the answer. The slope of the line between the points 2, negative 6 and 1, 3 is 9. Let's take a look at the graph and see what that slope looks like. So in this graph, I've plotted the points 2, negative 6 and 1, 3, and I connected them with the line. Now, that line is very steep. That's why the slope is a fairly large number. Also, you notice that we have a negative slope, and what that means as far as the line goes is that from left to right, the line is actually going downwards. So in our first example, we had a positive slope, and the line was trending upwards from left to right. In this example, we had a negative slope. The line is going downwards from left to right. To give you a better idea of what slopes look like, I drew this graph with several lines on it and labeled its corresponding slope. So you'll see this red line, both red lines have a slope of 2, but the line that goes from left to right upwards has a slope of positive 2, and the one that goes downwards from left to right has a slope of negative 2. The blue lines, they're 45-degree lines. They both have a slope of 1 and negative 1. As the angle sort of gets smaller, as the line becomes less steep, the slopes get smaller. Here we have a slope of 1/2 and a slope of negative 1/2. Now something you haven't seen yet, any horizontal line will have a slope of 0. And any vertical line actually has an undefined slope. Its slope would be infinite, so we call it undefined. Okay, video quiz time. Find the slope of the line between the points negative 4, 2 and 7, 3. Also, come up with 2 points on a line with the slope of negative 1/2. There are many examples of 2 points that would give you a slope of negative 1/2. Just come up with one.